This is, I couldn't print this off, guys, so I'll show it up here. I'll give you a copy of this, but this is the way we teach in motor control, and we use industry standard on how electrical controls are numbered. So this is actually a U.S. Steel print, and we got this from U.S. Steel. We taught a class. They used to teach for their electronic repairmen out there. They used to send them up. They had a school up there on the hill, and they'd send them up there and have them do these online things. And they had a failure rate of, it was unbelievable, like 90%. 90% on the electronic test. They were so desperate for electronic repairmen that they brought these guys out here 8 weeks, paid them full salary, came out here 8 hours a day, and we taught them electronics. And of the 15 people that took it, only one went back and failed that test. So what they did, part of the training was, and we covered basically PLCs and everything that was on the test, but we didn't teach the test because we didn't know what was on the test, but we knew the items. And this is the prints that they gave us, and this is where I worked at too. I worked out at U.S. Steel for probably about 4 years, I think. I started working out there. I was hired with a crew that when they fired up number 8 blast furnace, even though I didn't work at the blast furnace, I was hired in that crew. And then I left when they shut the plant down, when they built the pipe mill. So this is a U.S. Steel diagram. This is right down the line. Now, ABC is what we give on our test where the students have to identify this thing. But so notice every horizontal line gets a what? Yeah, 137-13. So this is page 137 of these diagrams. And this is line 13. So that's a pretty standard way to do it on multiple-page documents. Because this allows you to repeat line numbers. You don't get line numbers up in the thousands, right? These are wire numbers. So this is 132. So notice they start the wire number off with a page number, and then they assign it a wire number, 134111. But what I want to bring up is that this number right here and this number right here would be the same, considered to be the what? Same line, because they're in the same horizontal plane. This is a disconnect, so it's real hard to see. They call this PCL2 and PCL1. So they're still using the L1 and L2 designator, but they add a little more because they have multiple L1s and L2s throughout the system, right? Don't understand. But it's still L1 and L2. So generically, that's okay. These are relays. These are actually relays. So all in electrical motor control, the only symbol for relays is just a circle. But they don't have enough room to put the name, so what do they put the name at? On top. And then this right here says on this page, let's find something on this page. Yeah. And these are what we call numerical cross-reference numbers. So this is, I don't know what the 201 is. So this is on this page, 137, line 65. 5B, 2BR. Line, let me get a line that's on this document. Okay, so 130, this guy right here, I can't read it. 5B, 2 something. 137, line 6. 137, line 6.
Wouldn't it be that one, just that 5? Wouldn't it be that last?
That
one?
Yeah, that right there. So there's the contact right there. That's being controlled by what? By that relay right there. It's kind of blurry up here.
will the, contact only be affected by the relay that is directly before it?
No, it's affected by the relay that has the same name.
Oh, yeah. Okay,
Yeah.
sorry.
So why would they put a relay in front of that to delay it so it won't come on at the same time? Because look, they all repair.
What do you mean for the relay? These are relays.
I mean,
These
yeah,
are
the contact.
Well, they didn't want to control this one. They wanted all these to be controlled by this. But they didn't want this one to be controlled by that. So this is perfectly legal. So the only thing that this guy, only becomes true if if one of these over here is true. So notice this has several ways. We call this OR, by the way. So if this and this, or any of these are true, then that's going to energize this guy. It's not going to energize this guy. Right? You understand? Until, right? So this might be a control relay that has a ton of contacts on it. This right here might actually be a power relay that's actually turning on the motor. Okay. So what they're doing is this one picks up before that one picks up. Basically, it's almost instantaneous. I think if you looked at this one is actually controlling that one. So if this one don't pick up for some reason, what does that mean? Then this one.
That's what I was asking. I was like, is it with some kind of reason?
No, that's the reason. So one of them, you'll see this done a lot where they don't have a relay that's got they don't have relays that's got enough contacts. So what they'll do is they'll basically use two of them. And what they'll do for a little safety procedure is they'll make this one come in and then jump up. I'll see what you're talking about now. Yeah, so this right here, we're already talking a logic. We call this a logic OR. We won't get into that until later. And these are the only symbols they have in here. They're not showing any sensors or anything that's out there, even though there's hundreds and hundreds of sensors on here. And pages, good gracious, these things were. But what I wanted you to show you is that this is the industry standard, right? You understand? This is the way it's supposed to be done. This don't mean it's going to be done this way where you go to work at. But if you got any company that builds these panels for you, the diagrams they're going to draw is going to be according to this industry standard. So I don't think this is in the line numbers are on the left of L1, right? Numerical cross reference and comments. So comments is true. If they have comments on the rung, they write them over there by the numerical cross reference number. Wire numbers are color coded. So on a car, it would be color coded. Most of the time in the industry, you're gonna have one color wire, and it's usually going to be the same gauge. So I mean, the whole system is wired well. Yeah, it's wired with the same color wire. And then what they'll do at the terminals that connect everything together, this is where the wire numbers will be placed on the wires. And if you see two wires that have the same number, it means they are electrically connected. They're electrically the same. So that means I come over here and hopefully I didn't close that out. So I come over here. Here's the wire number right here, 137.011. If I see 137.0411, no matter where I see it, that's this whole wire right here. Y'all understand that? That's that common spot. L1 would have one number, L2 would have one wire number. And then if you get on those wire numbers, no matter where you find them in the system, that is L1 and L2. It's actually exactly right. It's the same circuit. It's the same connection. We have this in electronics where people don't realize these big old resistors and everything are not solid wires that stick up in the air, and they're trying to measure across the resistor, and they're trying to get into it where it comes in the circuit board. Instead of measuring it up on the big metal tabs, it's up on the resistors themselves, because that's just the way people see things. But you'll see people doing that all the time. They'll be trying to cram their meter leads down into our circuit. Where's the PowerPoint at, guys? I can close it. Oh, that's it. It was actually in the PowerPoints. Of course, I couldn't get the whole thing in there. And like I said, I'm gonna run this off. I'll give it to you. I get the printer down there won't feed paper for some reason, and I can't go. Location of each rung associated with the coil can be specified. The rung in which the normally open contacts are associated with. So this is where he's wrong. He's talking rungs when he should be talking lines. But when he comes back in his example is not right. So I've corrected it. By the way, this is another thing that we do. If I'm looking for a normally closed contact, see what they do? They underline. So notice I've come over here, I made this correction. I gave them line numbers, line 1, line 2, line 3, line 4. And now I can say, okay, M1, where's M1 contact at? In line 2. I find line 2, come over here, and what's that? M1. Okay, I got a normally closed contact in line 3. I come over here, find line 3, come over, and there it is, right? I got a normally open contact in line 4. I come over here in line 4. And you understand why what he said can't be right, because how many lines could be in a rung? Many. And so you identify rung 4, and you got 50 lines down there, and you're trying to go through 50 lines trying to find a contact, right? You understand? And this is not provided in PLC. So we don't get this over here. That option might be available if you print it. I need to do that and see if that's true. Clarify the control problem, draw a schematic diagram of the system. Technically, it's not a schematic diagram. Technically, it's what we call a ladder diagram. You want to see a schematic? So technically, a schematic is an electronic circuit. And then everything else after that we usually refer to as diagrams. Well, that's a pictorial diagram. Everybody's familiar with those, right? This is something called a wiring diagram. In HVAC, you're going to see a lot of it. It's very complicated to figure out. What they try to do on a wiring diagram is they try to place the components, basically how they're referenced inside the system. And components that are connected together, they put the same unit, they'll put in a little square. We call this a wiring diagram. That's not a good schematic. This is a schematic. This is a schematic of a power amplifier. It still uses nothing but symbols. This is a schematic. So a schematic, technically, if you looked it up, it's going to be an electronic drawing. And of course, this is ladder. This is technically, should be referred to as a ladder diagram, or what's the other name? A line diagram. This is the magnetic motor starter. How do I know? Overload. Usually has 3. More common now on most of your new ones. It's actually got 1 contact. This is a symbol for a line.
You said a schematic is technically a what? Not a line?
It's an electronic diagram using symbols. Drawn from left to right. So it's still the same. The signal flow in the US basically is left to right. So just about all our diagrams are drawn left to right, except for like how piping diagrams. If you ran pipes in a house, it's going to be drawn right from your input, right? You understand? HVAC diagrams, how to run your ductwork and stuff like that. It's not going to be drawn from left to right. Electrical diagrams or schematics are usually drawn from left to right. This is a power amp. This is where you need to put it over here. And all this is giving you all of, what is this, 1,000 watts of power to your speaker. Now, do you understand it? Why? Because you hadn't had that, right? But you do know it flows from left to right. The signal flow, not the power flow, the signal flow. The scheme of it's from left to right. These are transistors.
All resistors there.
Oh yeah, these are resistors. These
Low resistors.
yeah, these guys are connected in parallel because of the power. Some diodes in here. Yeah, there's some diodes in here. This is the Zener diode. These are bipolar junction transistors.
So that AC converter down there, like that. We're not even expected to know that much.
No, you're not expected to know that. You're not. But what I'm trying to show you what is schematic. So usually when you use the term schematic, we're talking about an electronic diagram. Is it wrong that he called it a schematic? Probably not. But most of the people that are in the trade would say, well, usually a schematic is an electronic diagram. I know how that works. And then this is what we're going to be dealing with, ladder diagram. And of course, here's the US Steel print. And we're not going to talk about one wire diagram. So we teach a class called technical drawing or blueprint reading. Even technically, these used to be called blueprints, but very seldom do you see blueprints anymore. And they called them blueprints because of the way they had to reproduce them. So they was usually either blue with white lines or they was white background with blue lines. And just about everything that you got was done that way. Now most of the stuff we got is either printed on a printer or it's ran on a plotter, a big plotter. And it's usually black on white, but we still refer to it. Some people still technically refer to them as blueprints. Okay, so that's motor controls. Now, a lot of times what you have to do when these guys get in there, and like I said, number 4 galvanizing line used to be all relay logic. It was divided into 3 sections. It was what they call the entry in, the process in, and then the exit. They had relay houses, rooms inside there. These guys were about back to that door over there, this long. Both sides, nothing but relays, and then big SCR drives and stuff like that was in there. And it was really neat because it was air conditioned. So the 3 relay houses were air conditioned. They came in there and replaced about 90% of that with PLC. I guess they still kept it in the same house before they shut it all down. I'm laughing because we were pulling new video cable in the powerhouse in Easley when they turned it off. So we were doing work over there when they shut it off the last time. That was weird. Because they'd already paid for it. We ran all this new cabling so they could tear it down. That's a true story. But most of our stuff, of course, is they're going to give us what we need to do, and then we're going to come up with how we're going to program it into our PLC. All we need to do in the next chapter is look at the difference between relay logic and PLC logic. And this is chapter 6. And guys, once we get with this, we can start basically going down there and actually punching stuff into the computer.
So 6 is preparing us for hands-on.
Right. The first basic circuits that we're going to be dealing with. And most of it we've already know. Basically, we probably know enough already, just what we've been doing. I've been popping into this thing, trying to get you ready as far as addressing and how to set it up and all that other kind of stuff, So this is PLCs. This is actually programming into an Allen Bradley. Now this book right here is written specifically for Allen Bradley.
You know, Mr. Priest, you talk a lot about Allen Bradley. How did it come up with that name?
By the two guys that started the company. They actually split off from, I think, Modicon. Modicon was the first truly commercially accepted major PLC manufacturer, a company called Modicon. The first PLCs that we got, but it was real big and everybody wanted in on it. So we had General Electric, we had some General Electric PLCs. We had some Square D PLCs, which they're real big in relay logic and stuff like that. And then Modicon came out basically on the company of its own. And these are the guys that left Modicon and started their own company. Kind of like Intel. Intel, Mitsubishi PLCs are out there too, but what we're talking about the main guys. Mitsubishi's still there. Okay. But when we start talking about PLCs, Allen Bradley, of course, Allen Bradley is name only now. Allen Bradley was bought out by Rockwell. So Rockwell's the people that make rockets and jets and all kinds of stuff. But they still carry that name. Why? Because everybody knows it. It's just like Jeep is not made by Jeep anymore, but they carry that name, right? You understand? Because that's what we know about it. Allen Bradley has been for years the dominant PLC in the United States. And what we find out is that we can't teach Mitsubishi, we can't teach this, we can't teach that, we can't teach this, but they all do the same thing. So what that means is if you learn how one of them works, it's one of those, so that's how they do it. So that's how they do it. It's just like the analogy I get is all cars almost have exactly the same thing. But when you go out and buy a new car, what's some of the things that's probably going to be different? How you turn the wiper on, right? You understand how you change stations on the radio, how you program the radio, but they all do the same thing. So when you get a new car, everything's in there that's from your old car. All you got to do now is figure out how they do it, right? You understand? So you don't have to learn every car. So, well, I got to change to a Ford. That means I got to learn how to drive a Ford. What do? You know how to drive. You got your driver's license, right? You understand. So this is what we teach. We teach the predominant PLC in the United States. And then if you got Mitsubishi's, you'll go what? Well, that's how they do it. Well, that's how they address. Oh, that's how they do timers. Oh, that's how they do counters. That's how they do that. They all do the same thing. In fact, we're starting to introduce Siemens. We still do Allen Bradley's in this class. Then in advanced PLCs, we'll pick up a little bit on Siemens. We'll let y'all enter a program, and you'll say, "Oh, that's how they do it," right? And that'll get your nerves up, and you'll say, "Well, it's not going to be anything." And then you go in, and when we move into, if you take the PLC 3 course, that's what we're going to do. We're going to play with Siemens PLC. And why Siemens?
Because it's expanding in the U.S.
It's expanding with German companies. It's expanding here, not in the United States. It's expanding here. Well, not even in Alabama. Here.
Here meaning this school?
Here because no, in our service area, because of one reason. Mercedes. Mercedes is a German company. When they built Mercedes, what PLCs did they put in there? Allen Bradley's. Why? Because there was already a base of trained people in Alabama that understand Allen Bradley's. What have they done now? They've changed over to Siemens PLCs.
So then you're
more
valuable as an employee if you go Siemens?
For them, or tier 1 manufacturers, because now they can have the same thing in all their plants out there. So they have the same robots, they have the same PLCs, so they're not trying to train their people on all these different technologies, right? You understand? So that's what they're doing. They're adopting over to the same thing. So they're going to KUKA robots for their they started out with FANUC robots. Why did they start out with FANUC robots? It was the predominant robot in the United States. There was a lot more people that knew how to use those things. Now they went over to KUKA. They went over to KUKA. It's not a German company, but it's a company that's made in the Netherlands. But it was the one they decided on.
I like trying to build the same car using metric versus standard components. You don't have to swap.
Yeah, you don't want to say, well, over here, this plant, you do it this way. Over here, this plant does it that way. And then, of course, if I'm working for Mercedes, if I'm building cells for Mercedes, and I'm building control panels for Mercedes, then I'm going to use what? Siemens PLCs. So just about 80% of the tier 1 manufacturers use Siemens PLCs. And that's what we have around here. When Toyota comes in there, I don't know. You know, that's something. Are they going to use Siemens or are they going to use Allen Bradley's? It would probably surprise me if they didn't use Allen Bradley's. But I don't know. Convert a relay logic program to a relay logic program. That used to be true. So we did a ton of this to start off with. Now most of your design is around what? PLC. Create a ladder diagram when the PLC is offline, and then download the PLC ladder logic program to test on a trainer. And they still do this. We was down at EDC, which is a company that's off the interstate down there, and they do modifications, and they've got a work cell down there. So they go in and actually work on that to get all the bugs out of it before they do what? They give it to Mercedes. Okay, so relay logic, are we okay? By the way, legally these are supposed to have dots. In electricity, if we don't have a dot, we don't have a connection. But what this guy's done, PLCs don't put the dot. To create a relay diagram, use input device symbols on that and output device symbols. Input and output port addresses are assigned to each input and output device. Each row is called a run. And that's what? Not exactly. Rule 1, place a contact in the upper left-hand corner of the ladder diagram. And rule 2, place L2 in one, place a coil at the end of the rung or on what? On the L2 side. Note that the addresses do not have to be assigned at this time. They didn't put that. They've already got addresses assigned to it. So all we're doing is just generating a basic way we're going to let this open out. And right now, we've only got 2 things. What are we going to put right here? We got 2 things we're going to put right here right now. We're going to put one. Either examine if closed or examine if open. Everybody understand that? Now, once you get into advanced PLCs, there's a lot of input devices that we can put over there that are not contacts. We can put decision making. We can put all kind of neat stuff over there. But in this class, the only thing over here right now is going to be either this symbol or what's the other one? Examine if open. That's the hardest thing to look at. People see this and they see this. We call this a normally open contact. But when do we want to get a signal back into the PLC? Not when it's open, when it's closed. So this guy right here is examine if closed. So that means if I come over here and press that button and close that contact, that data bit over goes to a 1. Right? You understand? So this right here, how can I tell if this thing right here changes state? When it's open. So this is examine if open. And I know that's confusing, guys, and I don't know any better way to teach it. Anybody got any suggestions? So we call this a normally open contact, but the instruction is called an examine if closed.
That's when you want to know what you need to know.
That's right. Yeah, like I said, guys, I know that's the 2 hard things to teach is syncing and sourcing. Y'all seem to latch on that really good. I really appreciate that. And then also examine open and examine. Now, when you key these things in, now this is laying it out. And most of the time, guys, if you look at the order of the layout, and this is up to you. This is totally up to you. When I come back and look at your book, there's a place where it says draw your ladder diagram. I mean, it's going to have to be drawn.
So that's a lot of work.
Now, when you do it, it needs to be there. It needs to be done by the time I come back there and grade it. Everybody understand that? If you want to do it first, that's fine. If you want to do it last, that's fine too.
Right now, today? Or-
No, when we do the lab, right? So if you got your lab book and you look at 6-2, about the fourth or fifth thing, it says draw the ladder diagram.
That's in 4,
Huh?
6. Oh, you mean, there's one you have to draw in 4.
Well, lab 5 also involved.
No, this is what we go to program the PLC. That's what we're looking at now. We're not talking about what's before this. We're talking about lab 6-2, I think.
I don't think I have anyone, not that.
Okay. Some of y'all don't have y'all's lab book.
I don't think you can use that.
So if you got your lab book, you can look at 6-2. That's the one I ran off this morning, so that's the one that's on my mind. All contacts must be placed horizontal. That's true. Everybody okay there? In fact, when you draw it, you can place them any way you want to, which is not legal. When you put them in the PLC, the only way you're going to put a contact is in there is what? Horizontal. Outputs cannot be connected in series with other outputs. Everybody understand that? The only problem in some versions of Logic Pro, it lets you get by with that. In the PLC, it will never let you get by with that. You'll get an error on that rung. You'll remember the error, it's got the E's over there. When you say verify the rung, it's going to keep saying what? Error. Down at the bottom, there's a little thing, a box will pop up and it'll tell you what's wrong with the rung. Note that the true ladder logic program application would not allow contacts to be placed vertically. RS Logic will display an error if the output is placed in series. RS Logics will allow outputs to be placed in series, and this is not true. I noticed that some of them will get errors. But we would have students that would, they impressed me. At home, they would do their whole ladder diagram in RS Logics, and then they would come in here. Unfortunately, the version of RS Logic, if you don't have the licensed version, you cannot save it and you cannot print it. Or you can save it, but you can't print it. So what they would do is they would bring their laptop in and they would do it at home. They would bring put their laptop there, and then they would key it in exactly the way it was in RS Logic. And then they could understand when they got errors. So RS Logics will let you get by with, it's a simulation. And you have to understand that that guy that programmed that thing had to anticipate everything that you would do. And what's the odds of that? So there's some errors in it. It's a very, very impressive program. And I think the license guys on it's like $15. If you really, 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 really want to learn Allen Bradley PLC, then I recommend you get the license on this thing. And they have simulation, they have lessons on there. They let you figure out how to run elevators. They let you figure out how to run street lights. So now even your street lights are controlled by what? PLC. Yeah. I think it's like $15 for it's a permanent license. But he only supports it for 5 years. So it means it don't delete after 5 years. It's just that he won't give you any upgrades after 5 years. You get it from the Learning Pit. And it's one word. In fact, I'll put a link up there on the Rule 5, program execution flows must be from left to right. And that's kind of true. Program execution is kind of it's actually signal flow must be from right. Left to right, no what? No backtracking. Now we've had people do motor control circuits. Well, the sensor, you actually do a little design, you know, put these back plug things out there, and not only dangerous, it's hard to figure out. Rung numbers on the left. That's true. If you're drawing it, if you're putting it into the program, it's going to do what for you? It's going to assign rung numbers for you. I highly recommend that if you draw these, you draw them in pencil. No. In PLCs, we don't deal with line numbers. In PLCs, we have rung numbers. So I don't care how many lines you put in there, then, and this is a big difference between PLC ladder diagrams and electrical control ladder diagrams. So chapter 5 covers electrical control diagrams. Here we're starting to get into PLC diagrams, and PLC diagrams deals with rungs. No matter how many lines you got, it gets one rung number. So when I come up here and start the PLC diagram, what's the first thing we're going to have to do when we configure, or it may be configure. So this is one little advantage of a fixed PLC over a modular PLC. There's an extra step in a modular PLC, and what's that? No, you got to configure. You got to select the processor on all of them. I don't care what you do, even the Siemens PLCs. So I was doing a little program today for the 1200, and I started a new program. They called it a new project, and what's the first thing I had to do? I had to select the processor. That's the first thing you got to do. Now the problem is on a modular PLC, you not only have the processor, it's over here by itself, but now you got all these dang what? Modules. So in a modular PLC, once you select a CPU, you got to select what type of modules you have, and you got to select what slot they're in. A fixed PLC, guys, you just come down here and do a, yeah, you select processor. So the one we got is the Micrologic 1100. So here's Micrologic. No, we got the 1000s. Okay, and then what do I need to do? So by default, Allen Bradley puts your end instruction. This will always be the last rung. So every rung we insert now is going to be put above it. So how do I do that? So here's my instructions right here. These are our basic instructions, user instructions. They also repeat in here, but this user, this has the most often used instructions up there for you. And of course, what I need to do, this is the symbol for rung. I'm going to come up here and turn that red. Then I'm going to come up here, and sometimes you can just click on it. And now it's another rung. Notice my end instruction automatically moved to rung number 1. And then I got to start putting input devices in here, right? Now you can come in here, you can put them in like this. What's going to happen on the Allen Bradley, it's going to put a little black mark thing up there, and it's going to put a question mark asking you for what? An address. So I'm going to come up here and just highlight it, and I'm going to double click on it. And that's, y'all used to double clicks. And then I'm going to have to enter a legal address, right? And we've already looked at the legal addresses available to us. So what I do first, I start off in, right? Colon, slot number. And since we're using, we can skip the word address. So we can skip go to the bit. Now when I enter this, what's going to happen on RS Logic is this screen right here is going to pop up automatically. It's going to be a big screen. And it's going to ask you for two things. It's going to ask you for a comment, but that's not important. It's going to ask you for a symbol. And what's nice about symbols, giving your symbols names. Huh?
They're shorter?
Well, no, they're just, you can give a symbol a name.
Oh, you can do anything you
Yeah. Now, normally what we'll do is the lab will tell you what the things are. They'll say the red light, and they'll call it RED underscore LT something. Well, what would probably be better is if you use that for your what? For your symbol name. Now, what's nice about using symbol names is that from then on, instead of entering the actual address, you can enter the symbol names and it'll fill in the address for you. Like I said, Siemens calls them tags. Now, what's going to happen on Allen Bradley, as soon as you hit enter on that address, another box is going to pop up there. And that box is going to have two things. The cursor automatically goes into the comment. It's up to you if you want to put a comment. They'll show up in yellow. But down below that is a little square that says symbol. And that's where you want to enter your symbol names. If you don't do that, then what can you do? You can just come up here and do what? Right click it and then go edit symbol, and it'll allow you to add a symbol later on. Are we okay? So how did the rung number get there? No, I didn't.
Oh, the run number was.
Automatically, yeah, it's automatically was put in there by the program. So like I'm saying, guys, when I come back and grade it, that chart is going to be back there. How you get it back there, I don't know. You don't see many people do the whole thing first and then program it in. They usually program it in and then come back and print it off. So normally that's the way they do it. So usually they don't ever draw it out anymore. But you're going to be required to draw it. That's part of the lab. Okay? In fact, I should probably be doing this on the. Now, on RS Logics, this is going to be green. The symbol names are green. And the comments are going to be what? Yellow. In fact, it's going to be black on the yellow background. I'll show y'all some of the PLC diagrams for our Festo line over there, and I got tons of comments in there, in both German and English. Festo is a German company too. So a lot of times you get these PLC books. It's in German, and I think the books for the Festo pneumatic trainers, I think they're in like 4 different languages. The books are about this thick, but the English part is only about. And we do that a lot. What's the 2 languages most of your stuff gets now? English and Spanish here. So just about everything you go out and buy something, it's going to be in 2 different. Here. Oops. Dang it. Thank God for multitasking, right? I remember on computers can only do one task at a time. Describe the major functions of the following runs. Let's see, specify location of each contact associated with coil. That may or may not be true. Place contacts next to the coil number of the rung. So this is what your symbols are going to do. What are you going to do with your every symbol? You need to do what with every symbol? Name. Now, once you've named a symbol, can you give that name to something else? You can give it to a contact that has the same name, right? You understand? But you can't reassign it to. I guess I should wait. You can't assign it to something new. Y'all understand what I'm saying? I know that's hard to say.
You can't use it.
For something new, you can't use it again. So I don't know how to say that. So I come down here, and I can come down here and I put another contact. I can't put a contact there, Rich. This still has an arrow, but I could come down here. I don't know if we'll see if RS Logic lets us do that. If it don't, then we might switch over to I'm saying Logic Pro. So up here, let's enter the symbol now. No, see, so Logic Pro don't let you do that.
You can't go in and change first either. I thought that was your question, was can you change?
Yeah, we can come up here and right click on it.
Okay.
And then, sorry,
Edit.
we can come and right click on it, edit symbol,
Okay.
and then we can come in and reassemble that now. Now, on what RS Logic would have just done, it was a did what for us?
Swap it?
It would put the address in there. So I'm gonna get at Logic. So Logic Pro is good. It's really good. In fact, there's some places that's teaching Allen Bradley's and they don't have Allen Bradley's. But unfortunately, it's not the same. So I'll come up here and say what? Okay, so this is what we're talking about. So I can come up here and I can come up here and insert a rung, right? Okay. Oops, rung, Rich. It didn't insert that time, so let's pull it down. Okay. Then I'm gonna put a contact in here. And then what I want to do is I'm gonna double click on this. So notice what happens as soon as I hit enter. I'm gonna enter an address on this one. By the way, another thing that it does for you is it'll give you the next available address, which is pretty neat. See what I'm talking about?
Yeah, could you just hit enter?
Yeah, and it would have gave you the next available address. Okay. And this tag has already been assigned to, so I could come up here, or I could come up here and I could type in start. And since this has been assigned, then what it'll do is it'll, hopefully, can you see what it did? It automatically gave it the same address. Right, but it's the same contact. If I was to come down here and if I was to come over here and put another contact right here, and let's say I wanted to give it another address. So if I come over here and tried to give it another address, I said N:1, if I say 1/2, sorry, these are all zeros. So that's an illegal contact anyway. /1. Okay, I'm gonna enter it, and then this is what I was talking about. So automatically it comes up and asks me for the one. A symbol. So let's try. Well, this is comments. This is where you'd enter comments right here. This right here is where you enter what? Symbols. Here's the address right here. This is black right now. You can see it wouldn't let me do it. Why? Yeah. So I'm gonna come up here. Anytime though, you can come up here and highlight it so it turns black like that. If it's the same address, you could do it again. Right? And then if I give it, and by the way, when I pop this up, notice what does it do? It automatically shows me what's been assigned. So it says start has been assigned to input 1/0, right? And it assigned me that. I'm gonna come up here and it says I got an error in the room. What's the error in the room?
You didn't fully address the second.
No, I don't have an output. And plus, yeah, I did address it. So some of the things we can do is we can edit the symbol. We can edit we can change what it is, change instruction type. So we can change it. Now notice it here, it actually put the instruction in there instead of the symbol. It says XIC. Yeah. So I can come in and do what? I can change it to XIO, right? And notice it changed the contact symbol for me. So you don't necessarily have to delete the contact. You could do it that way. That's one option you could do. You could delete it and then pull the other. By the way, to delete it, how do you do it? No, you don't. You could do it that way, but the best, I don't even know if you can right click. Is delete in there? Okay. Normally what I do is I come up here and I hit this big key on here called delete. So your delete key on your keyboard works too. So all you have to do is just do what? Highlight it and hit the delete key on your keyboard. You could right click. It'll delete it too. But I have a tendency to like to do things that are faster for me. So one thing this gives me a problem, 90% of the time the delete is where? At the bottom, where they got the delete at right here. And then this also shows you shortcut keys. So the shortcut keys that you learned in Windows also work too. So according to that, let's see if this works. So I'm gonna come up here and highlight this, and I'm gonna hit Control C, and then I'm gonna go down to this rung and hit Control V. Well, it's the same contact. That's what I was trying to do. I was trying to copy this thing. So let's say I wanted to set up a circuit that disables all the rungs. Well, the contact is going to be the same in the left-hand side. But instead of me going up there and grabbing that symbol and coming back in, typing in all that kind of stuff, what could I do? Yeah, I could just come in here. So I could come up here and you could, but if you do that, it moves it. I don't want to move it. So I can do that. I can move it between rungs. See that right there? But I don't want to move it. I want to do what? Yeah, so I ought to come up here and I'll just highlight it, hit what? Control C, come down here and do what? I'll just select this rung. We can come up here and hit Control X and then come down here and highlight this and hit Control V. So that way that's a cut and paste, right? You understand? And sometimes that's faster than trying to move it between rungs, especially if your rungs are pretty apart. So a lot of your shortcut keys that you learned in Windows are working here. Which y'all know those, right? Control C, Control plus C, Control plus X. Y'all don't know those keys? Hey, Grace.
I'm a right click guy.
You can do that, huh?
I'm a right click.
You're a right clicker? That's why these are called shortcuts. So your shortcut keys. Gosh, I thought everybody used Control C, Control V, and Control X. Or you can use the delete key. Okay, so what else they talk about? Let's take a 5-minute break, guys. So we've got in our 1747/L541. This is our CPU. Okay. Now you'd be, if you're in a fixed PLC, you'd be through. If you're in a modular PLC, what do we got to do? Yeah, we come over here. It says IO configuration. I'm gonna double click on that. First thing we do is select a rack. Ours is a 7-slot rack. And notice it automatically down at the bottom puts in the rack, the actual rack number. It automatically assigned the CPU to rack number what? 0. And then it shows you everything. What I like to do is just go like to inputs. Ours is the 1746-1NB16. Okay. It's on the door, right? And then I'm going to go to outputs. And it's the same thing, except it's output B16 right here. Okay, so there's our 2 outputs and we're through. Okay. And then I can come up and, all right, now Now what's the next one? Now if you're doing one of the 1,000 PLCs, once you select the 1,000 PLC out of that list, you're through. Because all your inputs and outputs are, and guess what slot number they use? 0, because there's no CPU slot. In fact, it uses 0 for your inputs and it uses 0 for the output, for the slot number. So calling it the slot number, that's okay. We can still call it that, but in fixed PLCs, there's not literally a slot, but it takes up a slot address. So I've got this highlighted. I can come up here and I can insert it. If it don't pop in there, just turn it down. You see the little thing turn green? Okay, and then that means that's where you need to put it. Of course, right off the bat, it tells me I have an error. Why do I have an error? Because I got a short circuit, right? Okay, so what does it say? We're going to come up here and put a push button. And I've got to assign it an address. So this says address input 0. By the way, we enter them in a line, but as soon as you enter it, the bit number drops to the bottom. Okay, see that? So I'm going to say input : 1/0. And then when I enter this, what's going to happen? It's going to ask me for a symbol, and I'm not going to call it push button. I'm going to call it PB1, which is a popular name for push buttons. I like to use all uppercase letters too, because they show up there. Still got an error. I'm not even going to check it now. Then I'm going to come up now and put another contact. Right? And then I'm having to assign addresses to these, not out of the book, right? And this is another one. This is input : Now look, it gave me the next free one. So if you want to do that, this is one thing we could do, right? You gonna say that? Okay. And then of course now, since I did that, I'm gonna have to give it a symbol name. And what we're gonna call this SW1 for switch. Okay, then what do I need to do? Probably not to put a bound. How you do the down drops, that's up to you. I'm going to go ahead and put the other contacts in there, and then I'll slide them inside this, slide it inside there. So what's this next contact on the same line? No, I'm doing the, hold on. And then I'm going to put 2. So 2, 3, right? And then we'll come back and edit the symbol. What are we going to call this? LS1. And then I'm going to come up here and I'm going to find this input 1/2. Oh, I've already used 1/2.
Are you copying that?
Yeah.
Because this doesn't have a fourth one on that.
Yeah.
Or you're.
Okay, I'm sorry. That's it. So what I need to do?
You need to label your output now.
Hit the delete key.
Oh, yeah.
First push button.
Okay, good. So what do I need to do? I'm going to come up here, I'm going to right click it, and then I'm going to come down here and do what? Change instruction type. And I'm going to put examine if open. Thank you. Then I'm going to come in here, just drag a down drop over here. And then I'm going to slide this guy into it.
Did you have to do that for the other 2 contacts?
Yeah, no, they're normally open. So these are okay. Okay, what else do we need in here? We need this guy. Slide it in right there. Are we okay? So there. So normally we put the down drop and we slide everything in there because once you put it, it's not going to go around something. It's going to do it like that. Okay. Anybody want to say that again? Anybody want to say that again?
Now, I was wondering why you did the first one and the other 2, because you saying that put it in there so you just turn it up, right?
You could put the down drop in there and put them in there and hit the ground, but for some reason I like to just put everything in there and then put the down drop and just slide what I need in there. Okay, so what's our output? Output colon 0/0. We're going to call this guy motor. And then I'll come down here and find this 0:0/1. Oops. Screwed up. And it'll probably, we're going to lose the symbol here. Output colon. I'm thinking the wrong PLC. What's our output? 2/0.
That's not what it says here,
Well,
but
that's-
it wouldn't be in 0, would it?
That's fixed in the book.
Yeah, this is a fix in the book.
Oh, okay.
We're trying to program it on this. This is the guy I'm going to run. That's my problem too. I'm looking at the book and I'm keeping forgetting that we're programming this PLC right here. And then we'll call this output 2/1. Okay, and then we'll call this RED understand. And then what we're going to do now is we're going to come over here and just click this, and it says that there's no syntax error. It don't mean it's not going to upload. But so if I use the wrong IO address, odds are it's not going to tell me that until I try to upload it, right? Understand? What's going to happen? I wish I'd have put something there on error. If you got an error in the rung, there's going to be another window that pops up down at the bottom, and it's going to point you to where the error is at in the rung.
Okay, I thought one of the rules was that outputs didn't have the same address.
They don't have the same address. I've given this output 2:0, and I've given this output 2:1. That's now it's when we're talking about electrical controls. When we're talking about electrical controls, that is true. When we're talking about PLCs, we can repeat the same coil as many times as we want. We don't normally do that, but like I told you, used to the scan of the PLC was so slow it would miss inputs. Because we come over and we'd hit a button and it's somewhere up here scanning because it takes so long to scan. So what we would do is we would repeat rungs, and when I mean repeat rungs, we would do what? Copy it. So in PLCs, you can use the same symbol name, but it's going to use the same address. And you're not going to get an error. So if you screw up, you screwed up. So that's why you need to give symbol names. So if you give symbol names and you accidentally use the same address, it'll populate that symbol up there, right? You understand? And you say, well, God, crap, I've used this before. Yeah, you can repeat addresses because they're logical addresses. They're not physical. In PLC, in these, they're physical, right? You understand? So I cannot use the same relay coil if there's another relay up there, right? You understand? PLCs, it's logical. So yeah, we can repeat contact numbers. We can use the same contact in different rungs doing different things. So this is programmed. This is soft. So if I want to use input 1 into this rung, so if this was electrical controls, once I put that switch right there, that switch is right there, right? You understand? PLCs, I can repeat that as many times as I want to. I can put that same push button in 15 rungs if I wanted to, which is slick because it's programmed, right? It's not physical. So that rule is a what? That's not a PLC rule. That's a what? The motor control.
So I got to kind of shake some of this stuff.
Yeah, these are computers. We can do a lot of things. Sometimes we do them inadvertently. But if you assign a symbol name and then you accidentally repeat the address, then that symbol will pop up there. If you don't assign a symbol name and use the same address, then by George, it's going to use the same input, right? Okay, is this it? Now notice when you program, your PLC has got to be what? Offline or in program mode. Now, the SLCs, we call these SLC because SLC 500, SLC 504s. It's got a key button on the front. Now, while that key is up, and a lot of your big PLCs will have that because you can put it in program to do what? program it, you switch it and run, and then what can you do? Then you can pull the key out,
And
right?
anybody-
And then nobody else can screw with it unless they got the what? Key. We've also got REM. What do you think that stands for? Remote. That means you can switch this thing between run, mode, offline programming, all that. You can switch it from this little button right here. Okay, as soon as I go online. All right? I like to use that because I don't like to keep.
Program, you got to be offline.
Yes. If you're online, they got what they call online programming. Online programming, you can change little bitty things. You can't change any addresses. You might be able to change the time of a timer, but you can't insert rungs. You can't actually do true programming. To actually do true programming, insert rungs, reassign addresses, assign labels, assign symbol names, you got to be offline. So most of the time when we create a program, we do it what? Offline. Everybody okay? I know it's getting close. Time to go. Then what do I do? Not yet. Download it. Now it's going to work. Now this is where you assign the program a name. How you name it, it's up to you. Normally what I like you to do is to, in fact, we'll probably do it this way. Use your first initial, last name, and then give it a number like 61 or something like that, depending on the program it is, right? And that way, if you come back to it later, you can pull it up. But you don't actually assign the program a name until you do what?
Right?
Until you download it. Processor is in run mode, so I've got mine in remote. It's going to automatically switch it to what for me? Program. By the way, if y'all got to go, you can go. We'll go back over this a little bit at the start of next class. But I'm going to go ahead and do it.
I think Lois are going to stay and do the
That's fine.
workshop worksheet.
By the way, if you go out that door right there, you better close it. Rich's wheelchair won't fit out that door. So that means if you leave it open, what do I have to do? I have to roll out that door, go all the way around and close the door for you. I don't mind if you use it, but just make sure you do what? Close it. Please. It's downloaded. Now it asks me, do I want to switch to run? Now, if you're using the key, what would you do right now? You'd go over there and switch it to run. Now, online allows us to monitor this thing. So right now, I've got mine on remote run, so we get switched to run. Right? It says this one right here is false, this one right here is false, so the run itself will be false.
Where does it say it's false?
If it's true, for what it checks on, if it's true, it's going to turn green like that. See that? The line. So now that one's true. So I've got it closed. It's saying examine if open. So it means this is going to be true if the switch is open. Another one is examining closed. This is going to be true if the switch is closed. This is up, right? Okay, y'all understand. Now my second output became true. Why? Because we've met everything that it needs to be true. Notice it's got the, right. Then the other one is what? Input 1, 2. By the way, this is going to confuse some of y'all too. The switches are numbered 1 through 7. The addresses are 0 through 6. So this key, this one that they got numbered 1 is 0. Right? You understand? That confuses me. By the way, y'all notice the light came over there. So that's 2. That's the one we're using, right?
That's the red light. Okay.
Yeah, that's the red light. And then this one right here, this comes true. The other light comes on. That's 1.
That means you did it right? That means
That's the most.
that's what you wanted.
That would be simulating the motor start. Yeah, that's what the program's supposed to do. But look, this guy right here is on, but it says it's false because it's an examine if open. See, you understand? So that means this guy here is examine if open, so it's true if it's open. So this is like a wall switch. When you want it turned on, if it's wired right, when you turn the light on, the switch is supposed to be up, right? And that's the way a wall switch is supposed to be, unless it's a three-way. So if I looked in here, this would be giving me a 0. This would be, these two would be giving me a 1. So what we've done is we've changed what's true and what's false.